Happy Friday! Today we're going to start on scale drawings, which again we're going to be using more proportions to solve this concept. So on your paper it says the formula. So here's our formula for scale drawings. So to find to solve a problem with scale drawings, we're going to use this formula here, okay? So model over actual equals scale and scale, okay? Or first to last equals first over last, okay? So both of these should be on your paper in the formula box. Okay, so let's take a look at the first one. We're just going to go ahead and dig in. It says if a scale is 2 centimeters. Happy Friday! So today we're going to be talking about scale drawings. So scale drawings include things like blueprints, or maybe you have like a figurine of the Eiffel Tower and they say it's to scale. That means that the dimensions are proportional. So again, we're going to be using proportions to solve this type of problem. So let's start out with writing in our formula box these two different examples, okay? So in general, a problem is going to give you the scale. So you're going to put the scale on the left side of the proportion, and it's always going to be model over actual. Okay, and then sometimes you're given your scale as a ratio. So first to last, and then first over last. And I know right now probably doesn't make much sense. Just make sure that these are both in your formula box, and then we'll go from there. And I'll explain it. It'll make more sense once we do the first example. Okay, so here is example 1. So it says if the scale is 2 centimeters equals 2.5 meters, so that is the scale, what is the length of the missing measurement on a scale drawing if the actual length is 150 meters? Okay. So let's see, we're going to start out with, like I said, we put our scale over scale equals model over actual. And kind of like measurement conversions, you watch the type of measurement and that'll help you set up your proportion, okay? So on the left side of our proportion, we're going to always write the scale that they give us. So here they're saying the scale is 2 centimeters. So that whatever goes first is going to go on top. 2 centimeters. That's why we wrote first to last is first over last. To 25 meters. So it's saying in this situation, something that is 2 centimeters long is equivalent to 25 meters. Just like on a map, if you're trying to tell how far apart something is on a map, it's proportional to how long it is in real life, okay? So it says, what is the length of the missing measurement given an actual of 150 meters? So they gave us our actual, okay? And we know that it's meters, right? And I see meters is on the bottom. So again, we're going to keep meters together and actuals on the bottom. So 150 meters. And it says, what is the length of the missing measurement? So obviously, we're missing our measurement right there. So you guys are pros at the rest, but we'll go ahead and do it together. So to solve a proportion, we do our cross product. So this diagonal, I have 25x equals and then 2 times 150. So I know 15 times 2 is 30, so 2 times 150 is 300. You always divide by the number with x. So I'm dividing by 25. Okay, well, I'll just go ahead and do it. I know how to do it mentally because I know 25 goes into 100 4 times, but there's 300. So 4 times 3 is 12, but we'll double check our math. So 25, 25. I subtract and I get 2 times 25 is 50. Okay, so x is 12, and then I'm going to look up here. So my x was on the top, which means it's a model measurement, so it's going to be in centimeters. Okay. All right, let's go ahead and try another. Okay. So on a map, 1 inch represents 20 miles. Okay. So it's saying that they're equal, right? So this is going to be our scale. If the distance between Atlanta, Georgia, and Nashville, Tennessee is 12.5 inches on the map, so that's like our drawing, what is the actual distance between the cities? Okay, so again, we do our scale on the left side, and then drawing over actual. Okay. So we're going to do our scale first. So it says 1 inch represents 20 miles. So first goes on top. 1 inch, that's my drawing, represents 20 miles. So that's real world, or 20 miles. That's real world. So that's actual. Okay, so we keep going. It says the distance is 12.5 inches on the map. So the map is my drawing, and I see inches here on top. So 12.5 is going to go on top. And that means, and it says, what is the actual distance? So I know actual is on the bottom, so I'm going to put an X. Now, again, we solve with a proportion. So 1x, or just x, equals 20 times 12.5. Well, I can't do that one mentally. So times 20, 0, 2 times 5 is 10, 2 times 2 is 4, plus 1 is 5, 1 times 2 is 2. There's one number to the right of the decimal. So x equals 250, and then since we're at the bottom, our actual, it's miles. So they're saying there's 250 miles between Atlanta and Nashville. So these are pretty easy peasy. As long as we set up our proportion right, you guys know how to solve it. So let's try yet another example. It says if the scale of a drawing is 1/4 inch equals 15 feet, what is the actual measurements for an item that is drawn at 9 inches? Okay, so again, scale over scale, drawing over actual. Okay, so the scale is going to go on the left. The first number always goes on the top, and it's inches versus feet. So inches is my drawing. So it's 1/4 of an inch equals 15 feet. So it goes on the proportion over here with it. What is the actual? So actual's on the bottom, so we don't know the actual for an item that is 9 inches. Inches is on top, right? That's my drawing, 9 inches. Okay. So let's go ahead and do our cross product. Yeah, let's see that. Okie dokie. So 1/4 x equals 15 times 9. 9 times 5 is 45. 9 plus 4 is 13. So 135. Okay. So I need to get x by itself. So right now it's times 1/4. So we're going to divide by 1/4. Okay. So if you guys remember back, 135 divided by 1/4. If you're dividing by a fraction, we can change it to multiplying by the reciprocal. So now I can just take off the 1 and I'm going to multiply by 4. So 135 by 4. Or you could divide by 0.25. It's your choice. 5 times 4 is 20. 12, 13, 14, 4, 5. So x equals 540. And it's actual, so it's going to be feet. Okay. All right, so blueprints, that's our real world application. So what are blueprints? So blueprints kind of give you a map, an idea of how something will look in proportion to another. So when you do a blueprint, like of a house, okay, so you're going to be able to see how big the closet is compared to the bedroom, right? So on a drawing, the bedroom and the closet aren't going to be the same size because that's not going to be right in real life, okay? So they have blueprints for all different types of things. Cars, houses, shoes, bridges. So blueprints are used on the daily by architects and engineers, mechanical engineers. So it's definitely something that is used on a daily basis, depending on your profession. All right, so let's take a look at this. This is exactly the same thing we've been doing. So it gives us our scale. So for each one, we know our scale. Our scale is going to be 1/4 inch or 0.25 over 15 feet. Okay, so each one you're going to be finding the actual. So each one we're finding our actual, and you're just going to plug your amount in to the top, okay? So 9 inches would go here, 12 inches would go here, 14 inches would go here, and 15 inches would go there. So plug it in, and then you're going to solve these 4 on your own. So press pause and do that. Okay, so the next piece is the word scale factor, okay? So scale factor means one thing. All you have to do if it says scale factor of, that means you're going to multiply, okay? So if it says you have a scale factor of 0.4, find the length of each measurement of the actual drawing. So literally all I'm going to do is I'm going to take my scale factor, oopsies, I'm going to multiply it by the length. So like for number 5, 150 meters times 0.4, 5 times 4 is 20, 4, 5, 6, 1. So 60 meters. That's it. Scale factor means to multiply. So finish those 3 up, press pause, and then we'll move on. Okay, so one last one here together. A picture has a side length of 14.5 inches. It is dilated by a scale factor. So dilated, like think of your eyes. Your eyes, when you get dilated, they get bigger, of 2.5 to create a new picture. What is the new side length? So scale factor is our keyword. That means we're going to multiply, okay? So it's 14.5, which I like decimals, so 14.5, and a scale factor of 2.5. So you just multiply by your scale factor. 5 times 5 is 25, 22, 5, 6, 7, 0, 10, 8, 9, 2, add 5, 2, 16, 3, 1, 2, 36.25 inches. Bam!